Are you tired of watching these videos yet? Well, you need to wake up because this is systems. And this one's important. They can be a little tricky. They can take a little bit of time. But if you know what strategy you need to use, you can totally get these right. They might be good ones to save for the end. But I'm going to go over the systems page with you right there. There we go. All right, great. So systems, what you need to remember, there are 3 different ways you can solve them. Substitution, getting a letter by itself and plugging it into another one. Elimination, also called linear combination, where you get either your coefficients, that means the number in front of your variable, so either the number in front of the x's to match or the y's to match, so you can add them together and get them to cancel out, or subtract them together to get them to cancel. And lastly, graphing. And I have a star by that because graphing is really kind of your always go-to backup method. You can always put your equations in y equals, graph them, and find where they cross. Now, when we get into systems of inequalities, you have to remember the answer isn't where they cross. It involves you making them shaded. So you're going to make it y equals, you're going to graph and shade. If it has the line underneath, you do a solid line. If it doesn't, it's a dotted line. And if you can read it as y is greater than, you're going to shade in color above. Y is less than, you're going to shade in color below. So let's take a look at these. Number 1, I would make them both y equals, and you can follow my work on how I did that there. I would graph each line, and then I would shade. So this green one says y is less than. That would be this line right here. The color didn't show up so great on this one, but I colored all underneath your green. Then I did the brown one, which was this line here. It was also less than, so I colored all underneath that brown. Now, you have to find the area where they are both shaded and where they both intersect, and that would be all of this right here underneath both lines. So D is actually the only one that has them graphed correctly. Okay. Number 2 down here, you're graphing both of these. What you want to remember is a y equals line goes horizontally, an x equals line goes vertically. So y is greater than 5 is this line right here. I shaded above. Y is less than 2/3 x plus 3. I started at 3, went up 2/3 to graph it, drew my line solid since the line's under it, and I shaded below, and the overlap would be this little piece right here. I go back up to number 3. Guys, just read that carefully and find the equations that match it. 2 dozen bagels and a delivery fee for $8, and so on and so forth. Number 4, you have a couple different options. I went with substitution since I already knew A was half B minus 6. And so in this top equation where A was, I plugged in half B minus 6. I kept the rest of the equation going as is. You can see where I continued my work over here, and I found out B was 6. So go back to either equation, plug in B being 6, work it out, and you'll find out A is -3. The other thing you could do is make these A's and B's, X's and Y's, and turn it into Y equals MX plus B and graph them. Okay. Number 5, anytime you want to know where 2 functions are equal, it's where they cross. So I had to graph this blue one, 2x minus 2. Watch out, your scale goes by 2s. So if I'm supposed to start at -2, that's actually only down 1 block. I do my rise over run, 2/1, and I'm writing down these 2 brown points where they intersect. The graphs cross each other. And notice here it just says what are the x values, so I'm picking -2 and 5 where they are actually crossing. Okay. If you flip to the back, number 6 is a question that you would probably see on like part 3 of your EOC because it's multi-part. It's got a lot of questions to it and a lot of different things they're asking you. But first thing, you need to write some inequalities. So Leah's trying to earn $120 per month. She makes $5 at babysitting and $8 at the ice cream shop, and she can only work 20 hours. So you want to put all your money together in one equation. Oh dear. There it is. So $5 for babysitting, $8 an hour for ice creaming comes out to be $120, and at least means she really wants more than that. And on the other side, she can only work 20 hours. So you add her babysitting hours and her ice cream hours, and she wants to come out working less than or equal to 20. So you would need to put both of these into y equals. You would graph them. This one says y is greater than, so you'd be shading above the line. This one says y is less than, so you'd be shading below the line. So this little bitty sliver are the only options for your answer choices. Now, if you look over here and at your part B, C, and D, part B says which ordered pairs work for the given conditions. Guys, you're just going to pick the ordered pairs that are in this shaded part right here. So be careful, pay attention, but those top three are the ones that live in the shaded areas. Those are your answer choices. Part C, if Leah babysits for 7 hours, how many hours will she have to work at the ice cream shop to still get at least 120? Guys, just go back to your equation up here. She babysits for 7 hours, plug in a 7, you'll get 35, subtract it from 120, and figure out, okay, how many of these hours would she have to work to still make her money? It'd be 11 hours. And lastly, part D, sorry, I'm gonna have to turn my head to read it. She wants to work as many hours babysitting as possible, but still make her 120 bucks. So you could actually look down here on your graph, if babysitting is on your x-axis, see how far can you go on that x-axis before you leave the shaded region. I know it's somewhere between 10 and 15, so I might start plugging in those numbers for my babysitting until I find the amount that would actually still get me $120. It turns out to be 12 hours babysitting and 8 hours ice creaming. Number 7, you have this little bitty system here. Change them to X's and Y's. You can graph them and see where they cross, but 2.5 pounds would be your answer. Number 8 right here, I forgot to write my answer down, but I could totally do this in like a table. Katie and Jennifer both start with 100 points. So draw yourself a table, put 100 for both of them. Now Katie is doubling. So Katie would go 100, 200, 400. That would actually be exponential. But Jennifer over here is increasing by 200. That's a constant rate of change, so she would be linear. So she would be 100, 300, 500. You're going to keep those tables going until you find out when Katie overtakes Jennifer and has more points. That would be after the 3rd turn. Okay. Number 9, if you want to know when these are going to be the same, just set them equal to each other, graph them, and see where they cross. It's going to be at 8 weeks. 11 and 12, you just need some way, somehow to solve your systems, guys. This one I'd probably put y equals, graph them and see where they cross. Number 12 here, I multiplied this bottom equation by 2 so I could get these to be opposite so I could do my elimination, my linear combination. I add them together, the x's cancel. That's the whole point of elimination, to eliminate something. So I add 8 and 3 and get 11y. I add these and get 55. I divide and find out that y is 5, and I can plug that into any equation to find out x is 2. Okay, and last but not least, you have these candy bars. You can turn them into these equations over here, okay, and find out that a candy bar costs 75 cents while a drink is $2. But the question on your paper is, what's the cost of a drink and 2 candy bars? So that's where I got this green answer of $3.50. So hopefully that helped you a little bit on systems. Just remember, graphing is your friend, and if you can put stuff into y equals form, you can totally knock it out and get it graphed. Good luck to you.